Let's go ahead and get started. Can you guys hear me? Can Chris and Marlena, can you guys both hear me? And Riley's here now too, looks like. You can either tell me through your speaker or you can just chat. Okay, very good. Marlena, let me know you can hear me. Excellent, very good. Well, welcome to another week. I'm just going to cover Chapter 10 tonight, and then next week we'll meet one more time, next Tuesday, same time, and we'll go through the last two chapters next week. But for this week, I just want to do Chapter 10. I was kind of realizing if I did all three chapters, it might just get to be too much and be confusing, and I thought I'll just do two more WebExes and just Chapter 10 tonight, and then 11 and 12 next week. So I put together an Excel file, and this is available under handouts, but I'm going to email this out to everybody also. And this file will kind of help you work on the homework problems for the week. And so the big topic for Chapter 10 is called capital budgeting. And what capital budgeting means is the process that businesses go through to determine if they should make investments in long-term property, plant, and equipment type assets. So if we invest in building a new factory or a new store or a new product line or whatever the project may be, the question is, will that be profitable? Will that make sense from a cash flow perspective? That's really the main topic of the chapter. So when you hear the words capital budgeting, just think it's the process we go through to acquire long-term assets and then invest in those projects, and then what's the return, what's the feedback we get, what's the money return that we get on doing that. There's several methods to go about doing this. NPV, which stands for net present value, IRR, which is called internal rate of return, MIRR, modified internal rate of return. Those are kind of the big three. There's also what they call payback and modified payback, and they all have their pluses and minuses. They're good and they're bad. Most companies will kind of run all five methods though, and because what you're looking for is consistency, and you're looking for, if I run all five methods, I should be looking for kind of the common theme here in terms of, does this project make sense? So that's kind of the background of the chapter. So question one, this is just coming from the back of your chapter. So I just did copy and paste just some screenshots from the ebook. And so in the back of the ebook, there are just a list of questions. So Chapter 10 exercises basically is where I'm getting these from. And just to show you examples of what you'll see when you do the work in MindTap. So this one right here, it says a project has an initial cost of $40,000. Expected net cash inflows are $9,000 per year for 7 years, and a cost of 11%. What is the project's NPV, or net present value? Begin by constructing a timeline. So whenever you see these, just think of a timeline. And the nice thing about these is that Excel does the heavy lifting for us. When I was an undergrad, back a long time ago, back in the 80s, Excel wasn't a thing yet. So everybody would use calculators. We'd use a business calculator or a financial calculator to do these. And you still can. And you can have an app on your phone that'll do that for you. But when Excel came out, the nice thing about Excel is that it will do this work for you. And that's what I enjoy about Excel, is it will just you can go through Excel and do this kind of work. And it's really makes sense. In my background, I worked a lot of years in financial accounting, where I was producing financial statements and reports that would get audited because I worked for a really large publicly traded company. And everything I did, auditors would have to essentially audit. And so when I was doing anything involving net present value or capital budgeting that would be boiled down into a journal entry and impact the financial statements, I had to be able to document that and show that to an auditor. So I quickly realized Excel will do this work for me. So I did everything in Excel because I can give a spreadsheet to an auditor. I can't give a calculation on my calculator to an auditor. That doesn't work that way. But I can give them Excel and say, here is basically the background, and here's all the inputs that went into my calculation. And they like that, because audits are done paperless nowadays. So them just getting the Excel file means they can audit the Excel file, double check the calculations. Basically, they would, part of what they would do would be to do the calculation on their own. Do we get the same numbers, yes or no, and go from there. So my background in the corporate finance world was to do this kind of stuff in Excel. So that's what I just like to use. That's what I like to teach. I think that's what you'll do. If you're doing anything like this currently in the business world, you will use Excel or something like it. There's websites you can just enter this kind of stuff into, and it'll calculate it for you also. So lots of ways to go around doing it. So I'm just a big believer in using Excel to do the heavy lifting for us. So the way I've got this set up is I have a little formula right here. And I just double clicked on that formula, and I want you to see the inputs and where everything's coming from. And the way projects work is you invest in a project. So at time 0, and time 0 is today, I spend money to invest in a project. And then in return, I receive a series of positive cash flows. So that's what every project is kind of geared towards. And so what they're telling us for this example is, they're saying a project has an initial cost of $40,000, expected net cash inflows at $9,000 a year for 7 years, and a cost of capital 11%. What is the NPV, or net present value? And now we haven't really gotten into too majorly yet the cost of capital. We have to some degree. We'll dive into that more a little bit in the future also. So let me hit escape on that so I can enter the numbers. So the way this works is I just literally put in the same numbers that came from the problem. So we're going to spend $40,000 in year 1, or at year 0, and then in return, I get $9,000 a year for 7 years. So I'm just going to do a copy and paste and just drag that across. One second. I'm using Screencast-O-Matic to record this, and sometimes it kind of fights me a little bit. So let me just copy this here. There we go. So now I've got that all ironed out. So what I want you to see then is when I go through and do this, I have to also put in the cost of capital right here of 11%. So I just want you to see that right there. And I don't know if you can see on my screen, sometimes I get an error message from Screencast-O-Matic. I don't know if you can see that or not, but the recording will probably have that on there, but now I've got it to go away. And that's the answer right there. So what I want you to see is that what that formula is doing, it's saying B11, and B11 is the year 0 amount, and I don't affect that by the time value of money. But then I'm taking B8, and B8 is the 11%, and then the sum of C11 to I11. And C11 to I11, I do have to bring back to the present value today, based on time value of money. So 1 year through 7 years back to today. And I net that. So basically I'm saying the net amount of these series of cash flows compared to the initial $40,000 cost gives me a positive number of $2,409.77. So what I'm saying is that if I do this project, I have a net increase of value to my company of $2,409.77 over the next 7 years. So the decision rule for NPV is if it's above 0, I would generally say yes. So based on what we see right here, we would go, yes, I would do this project. It makes sense for me to do it. Okay, so that was the first one, NPV. And then the questions kind of all refer back to the same inputs. So we're going to use the same inputs quite a bit, which will make this really easy to do. And so I'm just going to do a copy and paste for the second question. And just bring this in right here. One second here. My error message popped up again, so I got to get that to go away. There we go. And I'm going to copy that right here. And then with IRR, it's called the internal rate of return. I'm hitting my percent right there. And so think about what that means to be internal rate of return. I'm solving for a rate. So while NPV solves for a dollar amount, IRR solves for a percent. And the formula is called the IRR formula, as you see right here. And it's a really easy formula. It just brings in the sum of my initial cash outflow and all my positive future cash flows. That's my range right there. Okay, so I just want you to see that that's the range that I need to use and go from there. And it basically just returns a percent, and it's basically that's the percent return on the investment. So if I spend $40,000 today, get $9,000 a year for 7 years, I get a return of 12.84%. Well, That's higher than my cost of capital, which is 11. So again, I would say yes to that project. That project makes sense for me to do because the return is greater than my cost of capital. So that's the decision rule with that one. Now, I just want to caution you when you get these. What I've given you here is built on 7 years. So let's just do a hypothetical and say you have a problem in MindTap that says it's only for 4 years. Well, what you want to do is get rid of those extra numbers and then just change your formula to only pull in the specific range that you want to bring in. Okay, so then in this example, it'd be a negative 4.09, and of course I wouldn't do it then. But I just wanted to caution you, just make sure that Excel formulas are only as good as the input, and making sure that you've got all the proper cells brought in and the right dollar amount. So I just want to caution you, I've kind of got this pre-built for you, but you're going to get different scenarios when you do the work in MindTap, and you have to be ready for that and adapt the file as you see fit. Okay, so I just kind of showed you an example of what that would happen there. So let's go back and do the next one, which is MIRR, Modified Internal Rate of Return. And I'm going to do the same thing. I'm going to copy my numbers down again for us. And my screencast is kind of bugging me. There we go. And I'm going to bring this into right here and copy that in. I'm going to put in my 11% right here. And so you can see what my number turns out to be, 11.93%. And I want to just kind of discuss with you how MIRR and IRR are just a little bit different. IRR, Internal Rate of Return, has basically what goes into this is it assumes, and let me fix this to the original amount here. It assumes that all monies invested on a project, basically all returns on a project, are invested at the internal rate of return. So if I use IRR, what I'm assuming then is that all monies received in the future from this project are invested at 12.84%, the IRR rate. When in reality, that's not a great assumption. What's more realistic is that cash flows are reinvested at your WACC, your rate of return that you normally would have, 11%. So what's different between IRR and MIRR is the assumption that's built into the formula. Now, you don't know that by looking at the Excel formula. It's like, well, how would I know that? Well, the answer is you don't. It's just the way Excel was programmed by the folks that developed Excel, and it knows. So basically, it's saying it's going to change the reinvestment assumption and say it really makes sense for cash flows to be invested at the normal return rate, the WACC, which is the 11%. So notice it's a little bit lower, and that's going to be the normal case. Is MIRR will typically be lower than IRR. So all the same inputs, the only thing that's different is the formula. And now it brings into account the 11% up here. The IRR formula does not take that into account at all. So I want you to kind of notice that too. MIRR does take the rate of return into account. IRR does not. And almost always the MIRR will be lower than your IRR. That's a very common scenario. Okay, so 11.93 is my answer. So with this answer, I would still say yes to the project. The decision rule is my MIRR above my WACC of 11? And the answer is yes. As long as it's above 11, I would be inclined to say yes to the project. So at this point, I would still say yes. They give us the next one, which is called the PI, or Profitability Index. That's not one that I mentioned earlier. It's not one that is used as often, but it's a really good one. So I still want to make sure we understand it because, of course, you will get this when you do your MindTap work. And we're using the same inputs. And so what I put in here is, if you recall from the bond chapter and the time value of money chapter that we did previously a few weeks ago, one of the things I had you work on was to do present value, future value, all kinds of things. And it says for profitability index, so what you have to figure out is what's the present value of all the future cash flows. That's what I have to figure out. And to do that, it acts like an ordinary annuity. If you recall the definition of an annuity, it's a series of cash flows that are equal. They're the same. So I've got 1 through 7, years 1 through 7 here, where my cash flows are identical. They're the same. every year. So that's an annuity. And so I can just go ahead and figure out what's the present value of just those future cash flows. And so my payment is the $9,000 per year. The interest rate is the 11%, and it's for 7 years. And that gives me a present value of $42,409.77. And so I already had the formula built in right here, but what I want you to see is the PI formula is the present value of future cash flows divided by the initial cost. So the present value of future cash flows is the $42,409. The initial cost is that $40,000 investment. And so my profitability index, my PI, is the difference, or the division of those two, 42,409 divided by 40,000. And I get 1.06. So my PI is 1.06, which is my present value of future cash flows divided by initial cost. And again, the decision rule is if it's above 1, then I would be inclined to say yes. So it's above 1, not hugely above 1, of course, but it is above 1. And so I kind of want you to notice that so far the 4 methods we've looked at have all pointed towards yes, we should do this project. Okay, but you will get some questions over in MindTap about PI. And so when you get that, I think I have to figure out what's the present value of that cash flow stream. That's the number one thing to figure out. So this little exercise right here kind of shows you how to do that. Okay, the next one's called payback. And with payback, there's 2 forms of payback. There's one payback method that does take into account time value of money. There's one that does not. And the first one, that just the normal payback period, does not take into account the time value of money. So we'll go back and use the exact same inputs here. I'm going to type in our numbers here. So it's a negative 40,000 and then 9,000 a year for 7 years. So let me do that real quick. Okay, so you can see here what happens here. And I've already got this built into work. So number one, for payback, there is no magic Excel formula for payback. So we have to kind of think that through. Just like with PI, there really isn't a magic one formula that will do the PI for us, like there was for NPV, IRR, and MIRR. So with payback, the timeline approach that I'm using right here works really well. So you have a visual. You can kind of see here's what's going on. And what you need to recognize is when do the accumulated numbers go from negative to positive. And so the way this works is I've got that initial 40,000 cash outflow, and then my formulas are built in that with every successive year, as I receive cash that comes in, that nets against my cumulative cash flow, and you can see what happens here. So I've got 9,000 against 40, which is 31, 9,000 against 31, which is 22, and so on. And then I get from years 4 to 5, I go negative to positive. So my answer is 4 point something. So between years 4 and 5, I go positive. So I have to recognize that. So I'm going to double click on this so you can kind of see how this formula works. So the right here, the 4 is the G58. And then I divide that by the absolute value. So ABS stands for absolute value of the 4,000 divided by the 9,000 right here. And the reason I use absolute value is you can't divide by negative. So if I use absolute value, that turns it into a positive. That's the only reason I'm using that. You can't divide a negative number, otherwise your formula goofs up. So if I use ABS, that just turns that into a positive number for me. And so the answer is 4.44. So in 4 years and then 0.44 of a year, so close to half, you can kind of just round and say about 4.5 years I get my money back. Okay, and what is that good for? Not a lot. That would be my answer. It helps you just understand in 4.5 years my initial cost of 40,000 is recovered. And what does that mean? It kind of tells you the shorter that amount is, the safer the project is. It's kind of a general rule of thumb. So it's hard to know if that's good or bad, though, right? 4.44, is that good or bad? I don't know. Now, if I'm comparing several projects to each other, in this example I'm not, but let's just say I had like 2 or 3 projects I'm trying to compare to each other, and I'm trying to just pick the one that'll work the best, well, then I would rank them. I would go, which one has the shortest payback might be the one that I would choose then in that scenario. Okay, so it's just more of a matter of comparing it to something, but I really would never use payback as the sole reason for choosing a particular project. I'm going to rely heavily on NPV, IRR, MIRR. I will just tell you that payback is more of a nice to know, a nice to have. Don't be shocked if a high-level executive says, hey, what's the payback on that? And if you have the answer, great. But it really shouldn't be the sole method that we would say, let's lean on this one to make the decision. Okay, so that's payback. And the one flaw in payback is it does not take into account the time value of money. So we did not in any way, shape, or form discount any of these future cash flows down to a present value. We did not do that in any way, shape, or form. So one way to fix that is to use what they call discounted payback. And I want you to note we did not bring into account at all here the WACC, that 11%, never played into this at all. So what we can do to fix it is we can say, let's bring in time value of money. So I left the 11% there from our project. And I'm going to type in the numbers, because if I copy and paste them, it kind of goofs up my recording for some crazy reason. So I'm just going to type them in here real quick, so bear with me. But you can kind of see what the formulas are doing. I'm kind of auto-filling now as I do that. Okay, and so I want you to kind of recognize here, this goes positive to negative between years 6 and 7. So everybody kind of see that between the 1925 negative to the positive 2410. That's my range from negative to positive is years 6 to 7. So my answer is 6 point something, right? So I've already got that all kind of filled in down here for you to see that. I'm double click on that, and so I'm taking the 6 and I divide that again by, and this time it's negative I-73, so that makes it be a positive. So either the ABS for absolute or just the negative of that makes it work. And then 172, or I'm sorry, J72 is the other number that I'm putting into that. But anyway, that gets me to 6.44. If I did not put that little negative right here, I get the wrong answer. Okay, so it's got to be really worried about that. So I got to make sure I have a negative right there. Otherwise, I get it goes tilt and I get the wrong answer. Okay, so the nice thing about discounted payback, it takes all these cash flows and brings them down to a time value of money. And notice that keeps getting smaller. With every year, that 9,000 gets smaller. Okay, and I bring that into account when I convert this into my payback. So it makes sense that my discounted payback will be a longer time period than without doing the discount. So it's 2 years more. Just want you to kind of recognize that. And again, discounted payback, it does solve the issue of time value of money. But again, it's not necessarily the reason I would use to select a project. I'm going to, again, lean really heavily on the other methods, NPV, IRR, and MIRR. Okay, we'll do one more, and then we'll let it go. Yep, that was my last question right here. So question 7 is the last one. And now we have new inputs now, new numbers. And it says your division is considering 2 investment projects, each of which requires an upfront expenditure of $15 million. You estimate that the investment will produce the following net cash flows. So both projects require a $15 million investment. Project A has 3 cash flows, 5, 10, 20. Project B has 3 cash flows of 20, 10, and 6. Now I want you to recognize when you see the timing of these cash flows, that matters. You know, Project A, the biggest year is year 3. For Project B, the biggest year is year 1. And keep in mind that the further away we get from today, think of today as time 0, the more that time value of money impacts the answer. So 20 million in 1 year is not discounted as much as 20 million in 3 years. So I just want you to kind of visually kind of appreciate that. And then the question is, for part A, it says, what are the 2 projects' net present values, assuming cost of capital of 5, 10, and 15? So let me just show you how to calculate that right here. So we can just do the first project. We'll type in 5 for the first amount, and let's just go ahead and do the negative 15 because that's the same for both projects. Okay, and let's type in project A first. So we'll go with 5 million, 10 million, and then 20 million. Okay, and I get the 16,108,951. So I just want to double click on this formula so you can kind of see how it turns out. And you can see I'm using that 5%, and it's bringing the range of that negative 15, which is the B101 right here. The B98 is the 5%, and then the C, D, and E 101 are the positive cash flows. So you get 16,108,951. So I want to show you up here. I kind of just pre-populated this little table here just as in the interest of time. So NPV for project A at 5% is the 16,108,952. So what's nice about using Excel is if I just change one input, I get my new answer. Okay, so if I change that to 10, I get 12,836, 12,836,213. If I change it to 15, I get my final answer. Whoops, I did that in the wrong spot. Do that right here. I get 10,059,587. So what I want you to recognize too is the higher the higher the rate, the higher the WACC that we use, the lower the NPV. Okay, so kind of just recognize that. So companies that have a lower WACC will have more projects that will be acceptable, right? The higher the WACC, the less likely I would take on a particular project. Let's do the same thing for project B. Let's go ahead and put in the numbers down here for B. I'm going to go back to 5% and put in project B's numbers. So the initial cash outlay is still 15 million. So I'll go to 20 million. And then I go smaller. I go to 10 and then to 6. Okay. And I get 18,300,939. My number right here. 18,300,939. And then I go to 10%. It goes to 15,954 right here. And then we'll go to 15%. And we go to 13,897,838, which is this number right here. So again, same pattern, right? The higher the interest rate, the lower the net present value. But I want you to recognize the timing of the cash flows mattered. That for project B, comparing B to A, under all three scenarios, project B is the winner. Okay, so that's just kind of one little rule I want you to remember as a takeaway from this particular chapter is timing of cash flows matters. Okay, big time it matters. Now the second one that they want us to do is to actually do the IRR calculation for both projects A and B. And that's already built in down here. It's right here. And so remember the IRR formula is really simple. It's just literally bringing in the range of numbers. So it's B101 to E101, which is my negative 15 all the way to my 6,000. And IRR does not take into account what the company's WACC is. So what the WACC is never comes into play to do this calculation. And what I want you to see is for project B, it's 82.03. No matter what I make this percent B, it never changes. That 82.03 doesn't change. Okay. So I want you to kind of recognize that. So that's why it's the same number for all three. So if I go back and re-enter the project A numbers, let's do that real quick. I guess that was the same number in both. 20 million for the last year. I get the 43.97. Okay, and that never changes. 10%, 5%, 15%. It never changes. It's always 43.97. So I just want you to recognize that also. Then also recognize that timing cash flows matters. The IRR on project B is huge. It's 82% versus 43.97%. So both are really good projects. Both these projects are winners. Under even a 15% cost of capital, they work. Now, at 15%, project A won't work or B won't work because the initial cash outlay was 15. A won't work under $15 million, but B would work, right? And then, of course, these both work. But then also recognize, here is the situation where I have to be careful about making sure I use all the methods. My cost of capital is either 5, 10, or 15, but I want you to recognize that no matter what, project A returned greater than that, and project B did also. So, but I have to be really careful, okay? So, because under project A, 10% and 15% don't work compared to a $15 million outlay. For B, 10% will work, but 15% won't. So this is why you do all the methods. That's why I do NPV, IRR, and MIRR, because I want to make sure if all three align to say yes, do the project, then I probably will do the project. But if only one says yes and two say no, I'm going to go, I'm not going to do the project. So that's kind of the takeaway I want you to come up with here. And if you ever are in your current position or a future job, and you're thinking, somebody's asked me to do some analysis of should we invest in some kind of a project, have some tools to kind of figure that out. I just kind of want you to recognize that. So this Excel file can be one that you can use quite a bit. And then also I want you to kind of recognize that every chapter has what they call a toolkit Excel file. And so for chapter 10, if you go to my.usf, click into our class, and you look in our class under, I think it's under handouts. Every class is a little bit different. Let me log into my.usf real quick here on a different screen. And I just want to double check I'm sending you to the right place. If you go to main page in our class in my.usf and click on handouts, and then you scroll down to the appropriate week. For example, if you look under week, it's actually under week 5 in handouts. My weeks are a little bit goofed up, but there's a chapter 10 toolkit Excel file there that you'll see. I would encourage everybody to open that up and just look at it. As you go through the ebook, you'll actually see screenshots of that same Excel file in your ebook. And just kind of take a look at that. It's got a really good tutorial in there of all the methods. And so that's where I got this from. All I did when I did this stuff right here, this is just a copy and paste from that. And I just kind of highlighted the sections that we would need to go over. So on your own, I would just suggest that you take a look at the toolkit Excel for chapter 10. I think that'll help you quite a bit, just to help you kind of visualize a few things. And it's kind of like a little mini version of the textbook. So I'd recommend that you do that. You will not waste your time doing that. And then within the chapter itself, as you go through the chapter, it has little self-test questions in the chapter. And the answers to those little self-test questions are in the toolkit. So there's various tabs on the file. And there's like a tab called 10.3, 10.4, 10.5, 10.6, 10.7. Each tab is how to calculate the answers for a particular self-test question that came from the chapter. So if you want to kind of just practice something just to kind of build up your confidence and feel like, okay, I know what I'm doing, you can definitely take a look at those. You will not waste your time. It will help you out. And then I would also say save these files somewhere. So save them on a flash drive or your laptop hard drive. I've had students email me years later, years after taking some of these classes, going, I have to do some of these calculations at my job. Can you send me those files? I can't find them. I'm like, sure, I'd be happy to send them to you. So I've actually done that many times. I've sent some of these files out to people because they're making these calculations now at their jobs. So I would say save these somewhere so if that ever comes up where you work, you've got some tools now to kind of help you out with that. Okay, so I'm going to wrap it up then with that. Chapter 10 is pretty straightforward. I don't think you'll struggle too bad with it, so it's just the one chapter that's due this week. Then next Tuesday night, a week from tonight, same time, we'll cover the last 2 chapters of class, and we'll talk about kind of just the final things to wrap up. Okay, any questions from anybody? Lynette, Marlena, Chris?
Thank you.
Okay, you're welcome. Appreciate you guys all being here. Have a great rest of your nights. Thank you.